look at two different things. We're going to look at sound intensity and sound intensity level. And it can be really tricky remembering which one is which because they sound so familiar. We have sound intensity and sound intensity level. But that's why I actually do it in one lesson. We cover them both in one lesson so you know the difference between them. So we know sound is a form of energy, and a wave is something which carries energy. So a sound wave carries sound energy. So we have a sound wave moving through the air. It's carrying energy from one place over here, let's say point A, to point B here. Obviously, different sound waves can carry different amounts of energy. So we could have a high energy wave, or we could have a low energy wave. Different waves have different waveforms, different wavelengths, different amplitudes. They all carry different amounts of energy. So what sound intensity is it's the measure of how much energy is falling on 1 meter squared per unit time. And what I mean by per unit time is per second. Now, we already know that energy per second is known as power. Power is the amount of energy per unit time, per second, and the unit of power is watts. So sound intensity has the symbol I, and it is the amount of power, or the sound energy per second, falling on every meter squared. So that means its equation is power divided by area. So the unit would be watts divided by meter squared, or watts per meter squared, like that. And that's the unit of sound intensity. So for example, if something had a sound intensity of 100 watts per meter squared, what that means is on every meter squared of surface, there is 100 joules of energy, sound energy, falling per second, because 100 joules per second is 100 watts. So that's what it means. This is the definition here in the red box, and you need to definitely learn it. So sound intensity is the rate of sound energy, and that rate of sound energy, remember, is power. Instant basically just means falling on 1 meter squared at a right angle to the direction of motion. And that last bit, at a right angle to the direction of motion, is important. It's measured on how much is falling at a right angle to it. So if the surface is here, it's falling perfectly at a right angle to it. So that's sound intensity, and it's basically a measure of the amount of energy something has, or energy that's being carried. Now, I just want you to imagine you have some object here, a little speaker, and it's giving out sound. Well, that sound is going to travel in all directions. So it might start here, then it will move out and out and out, so it travels further and further away from the sound source. Now, if we wanted to know the intensity, let's say at this point here, what we need to have is we need to have 1 meter squared. And we need to figure out, well, what's the intensity of the sound that is reached here, given that this is the radius r. Now we know intensity equals power divided by area. So the question would be, what area would we use here? Now this isn't a good drawing because it's 2D, but I want you to imagine that this is a 3D sphere. The surface area of a sphere is given by the equation 4 pi r squared. So let's say we had 100 watts of sound energy starting out at this point. That 100 watts is going to spread out, isn't it? So at this stage it's going to be spread out through this circle, and then as it moves through the air it's going to spread out further and further. So if you think about it, if I had 1 meter squared here at point A and 1 meter squared at point B, you'd expect there to be less energy at B, because as this sound moves out, as it spreads out through the air, it's forming a bigger and bigger sphere. And I know it's hard for you to see here because this is 2D, but imagine this is a 3D drawing. Now if we wanted to find out how much energy is at 1 meter squared at a radius r from its original point, what we'd have to use in our area part of the equation is the surface area of the sphere, because that original 100 watts is being spread out over an area of 4 pi r squared. So let's say this distance here was 8 meters or 2 meters. And originally there was a power of 100 watts. That would be 100 over 4 times pi times 2 squared. And whatever that answer is in watts per meter squared. And that's the sound intensity at that point. If we went closer in, if we were here at point A and the radius is only 1 meter, what you're going to see is you're going to have sound intensity is 100 divided by 4 pi 1 squared. And you can put that in your calculator to get the answer. But what you'll notice about that answer is that it is bigger. For point A, the answer is bigger than what it is at point B, because the sound energy hasn't been spread out as much. The further away it goes from the center, the more spread out it is. So we're going to look at an exam question which kind of uses this fact, and I haven't realized it, but I've actually picked the same numbers or similar numbers. So this is the 2011 question 8 part B. So we have a speaker which is emitting sound uniformly in all directions at a rate of 100 watts. So we have a sound source which is giving out sound at 100 watts and it's going out in all directions, like this. Calculate the sound intensity experienced by a listener at a distance of 8 meters from the speaker. Well, 8 meters away, that 100 watts is going to have to spread out through the area of a sphere which has a radius of 8 meters. So to get the sound intensity, it would be I equals power divided by the area or surface area of a sphere, which is 4 pi r squared, which is 100 divided by 4 times pi times 8 squared, and that gives you an answer of 0.124 watts per meter squared. Part 2 we can't do yet, but we'll be able to do it in a minute. So that's sound intensity, the energy falling on every meter squared. Now the next thing we're going to look at is sound intensity level. Sound intensity level. And it can be hard to get the two of these, or not to get the two of these mixed up, because they sound very similar. But sound intensity level you will have heard of before, you definitely will have heard of in junior cert at some stage. Sound intensity level is measured or compared using the decibel scale. And what it basically is it's a measure of, I suppose, loudness really. But obviously there's a correlation between the measure of loudness and how much energy something is carrying. So there's definitely a relationship between sound intensity level and sound energy. And what the sound intensity level is really, or the sound intensity level scale or the decibel scale is it's a scale starting at 0 decibels, going all the way up to about 140 decibels, because that's kind of what most common everyday sounds wouldn't really go higher than that. So 0 decibels is the lowest number on the sound intensity level scale or the decibel scale, and it's also sometimes known as the threshold of hearing. And the reason it's known as the threshold of hearing is because it's not actually no sound. 0 decibels is not complete silence. 0 decibels is actually the minimum sound or the quietest sound that a human being can hear. Because people always think 0 decibels means there's no sound, but actually it's the lowest sound possible for humans to hear. When you go to about 20 decibels, that's kind of maybe whispering. That's about as loud as someone is whispering. If you go up to 60 decibels, that's maybe a conversation. So that's probably the volume you're kind of listening to this at, or me speaking now. Once you go up to maybe 90 decibels, you're looking at maybe the loudness of a lawnmower. And above that, like 140 decibels would be a jet engine or something like that. And this is all in your book as well, and I'll give you the page number in the comments. Oh, I have it here actually, page 192, 193. So you can have a look at the full scale there and read it as well. Now, once you go above 85 decibels, it's really, really bad for your hearing. So this is what's known as kind of the danger zone, I suppose. That if you go above 85 decibels, and you're exposed to those sounds for a long period of time, it can damage your hearing permanently. So lawnmowers are 90 decibels, and 90 decibels isn't that far above 80. So we can kind of put up with listening to a lawnmower for maybe 5-10 minutes when you're using it, and it won't really do any damage to your ears. But if you were a landscaper and you were working on a lawnmower every day, all day, or you were driving a tractor all day, every day, you need to wear hearing protection, because long exposure or lots of exposure to any sounds over 85 decibels can cause a lot of damage. And obviously the higher that decibel number is, the more damage it can cause. So you've shorter amounts of time there. So you might be able to spend 15 minutes listening to a lawnmower with no damage, but you couldn't spend 15 minutes beside a jet engine. Your ears would be damaged in a much quicker time because it's a higher decibel level. Now here's the thing you really need to remember with the decibel scale. It's not a linear scale. And what I mean by that is 20 decibels is not double 10 decibels. And that would be the case in a normal linear scale. It's a log scale. And because it's a log scale, there's a separate set of rules, and you just really have to learn this off. And the rule that you have to remember is every 3 decibel rise means sound intensity, and sound intensity is what we've just covered. Remember, talking about energy, means sound intensity doubles. Sorry, the pen is getting a bit messy here, but that's what you need to remember. So for example, if we had a 6 decibel rise, that would mean that the sound intensity level has doubled twice. So if it's doubled twice, it would have increased by a factor of 4. A 9 decibel rise means it has doubled 3 times, so that means it would have increased by a factor of 8. It's 8 times, carrying 8 times more energy. The sound is carrying 8 times more energy than it was originally. Obviously then, if the sound goes down by 3 decibels, it means the sound intensity level has halved, or it's half of what it originally was. Okay, the video is getting a bit long now, but one really quick question. This is the 2009 question 5D. So the sound intensity level goes from 85 decibels to 94 decibels. By what factor has the sound intensity increased? So to go from 85 to 94 decibels, that should be a small d, capital B, yeah. There is a 9 decibel increase. So for every 3 decibel increase, the sound intensity doubles. So it will be multiplied by 2 once, multiplied by 2 twice, multiplied by 2 3 times, because it's a 9 decibel increase, so that would be, it would increase by a factor of 8, and that's your answer. Factor of 8. Okay,